Hello and welcome to Bungalows for Bachelors number 15. Today we're going to learn about roofing. So let's jump right in. Share my screen. All right. Phase 3, building enclosure. So we got a foundation built. We got our framing built. What's the next thing? We want to protect our framing from the weather. So we want to put a roof on it. So today we're going to learn about roofing. Well, what is roofing? I'll make sure my screen catches up here. Is it going to catch up? There it goes. What is roofing? Roofing is, generally speaking, the materials added to your roof deck to protect your home from the elements: rain, hail, wind debris, snow, ice, that kind of stuff. So, you have the sun. That's another one. So that's what roofing is. It's the stuff that's going up on top of the house that's going to do all that stuff. What is the purpose? Well, like I just said, it's shedding rainwater off and away from your structure, blocking UV rays from damaging your building materials, and it is providing a replaceable layer of protection from being damaged. If you were just to leave your roof structure out in the exposure and it were to be damaged, it'd be much more expensive to replace all your framing than just your roof. So what is going on here? How did that happen? Okay. Let me go back. Okay, so that's the purpose of roofing. That's what it's doing. So typical scope of roofing is going to start, if you're a roofer, you're going to show up to a job site and there's going to be a totally framed house that's been totally sheathed, and you're going to begin with a blank roof deck, and the fascia boards will be installed. Fascia board being the board that defines the edge of the roof, so that you can start with your drip edge or your underlayment, things like that. So that's where you're going to start, and that's where the roofing happens, and it goes until you have a roof structure that's totally on the top. On the photo on the right, that's what's going on. There's a little bit of house wrap started on the bottom, but you get the idea that the roof is complete up on top. This is one of the first times you're going to see the finished surface on a new house that's being built, because you're not going to do anything to modify this roof afterwards. It's going to stay like that until the house is done. So that's kind of cool. What types of roofing are there? Well, the most common one that most people will think of is probably asphalt shingles. Photo on the left is showing some architectural style asphalt shingles on some houses. And that there are multiple types of that. We'll get into that later. But second to that, most common, most likely, is metal roofing, depending on where you are, of course. But there are multiple types of metal roofs. There's, some prefab, and there's some standing seam rolled stuff that's cut on site and stuff like that. There's Tesla roofs, which is fairly new. Tesla came out with basically a bunch of, they're effectively solar tiles that look kind of textured. They look kind of cool. We'll talk about those later. But they are effectively, some of them can be hooked up to the solar absorbing, solar panels. Basically, your roof is all solar panels. Fairly new product. F-Wave is another new product that is basically a synthetic shingle. We'll talk about it later. It's designed to basically not be made out of asphalt, and it relies on synthetic materials. So it's just another brand. Cedar shakes is another style. That's effectively where you're taking a bunch of split pieces of cedar and nailing them up just like shingles would. It's a much older style. It's pretty much what people had to do when they didn't have anything else to work with. It's just an older style of roof. It looks really cool, but it's hard to maintain and keep it looking nice. There are tile roofs, which is like the photo you see on the right. There's many types of tiles. We'll talk about those later. There's some ceramic tiles, clay tiles. You see a lot of this stuff in areas that are going to be exposed to a lot more heat. The ceramic and the masonry products are going to handle that heat a whole lot better than all the other products. Places like Las Vegas, Nevada, or the desert, or someplace in California where you just get tons and tons of heat and UV rays and sun, these roofs are going to last a lot longer. So you'll see them there. And then rubber roofs. So there's kind of two types of rubber roofs. There's the like a one what's the word's not coming to mind. Single ply, that's the word. Single ply roofing membranes that are usually reserved for like flat roofs, gas stations, industrial buildings, stuff like that, where it's super low slope and you need a really good seal. They're basically going to take sheets of rubber and they're going to glue them together and melt them, seal them together. And then there's actually recycled rubber shingles that are made. And we'll talk about some of that as we get into it. So the first one, the asphalt shingle. So there's three general shapes you can buy this in. There's a three tab shape, which is the bottom left photo. There's an architectural or dimensional style shingle, which is top right photo. And there's a luxury style shingles, which is basically any other cut you could imagine that's fancy looking, that's textured and all this other stuff. You can get all kinds of shapes. That's what the luxury ones look like. They are, of course, the most expensive. But in terms of how long things last, the three tab shingle is going to last the least amount of time. And if you ever got your hands on them, you would know that the three tab shingle is basically just the single ply of shingle. It goes on, it's the cheapest one. It'll get you maybe, it claims like a 15, 20 years, maybe 25, but you're going to get, 10 to 15 years out of it most of the time, unless you're in a super hot place and you're going to get even less. And then there's architectural shingles. Those are normally claimed to be a 30 or 35-year roof, and you're actually going to get, 20, maybe 25 years out of an asphalt shingle. They are almost twice as thick. They have much more texture to them. They're just a much tougher product. And the luxury shingles are also going to be about as tough as those architectural shingles. There's two base materials that are selected when making asphalt shingles. It's important to know which one you're buying. There's organic, which is basically a paper fiber that's mixed with the asphalt, and that is the base. They sprinkle the ceramic granules on that. And then there's fiberglass matte base where you actually have fiberglass. So there's kind of pros and cons. The organic is cheaper to make, and usually when things come cheaper, they don't last as long, and that's true. They're fairly easy to damage, not very strong, fairly easy to break, not very good at handling in terms of installation. They could break a lot easier too. And fiberglass shingles are going to be much stronger because fiberglass is just a stronger material when mixed with asphalt. And fiberglass is going to be a little more expensive than an organic base, but you're going to get a much longer lasting product. It's going to be much stronger. The only downside to fiberglass is when it gets cold and brittle, it does have a tendency to break as well. So types of metal roofs. We're going to talk about non-structural metal roofs because people don't build structural metal roofs in residential construction unless they're building like barn dominiums and stuff like that. And then maybe. But basically, all the metal cladding that we're talking about is designed to cover up. It's designed to be aesthetic. It's designed to do its job. It's not holding any serious weight. So there are pretty much many kinds of materials. There's aluminum, copper, galvanized steel. There's like tin, and there's like zinc coated, which is just galvanized steel. And there's a few different types of metal to pick from. And aside from that, the next thing to think about is going to be the shape of the roof you want to see. Like how's it going to be installed? What do you want to see? A corrugated steel panel is going to look like the one in the top right photo. These are typically cheaper to buy. You can buy them in like 12-foot lengths, things like that. And they're just one big chunk. They're usually 3 feet wide, something like that. And they just go on in panels. And it's usually the most affordable option. You'll see them on chicken coops, sheds, things like that, where they're, people aren't super concerned with price, but they want something that's going to last a while. And those are usually nailed down with exposed fasteners. Those are two types of ways to fasten a metal roof down, either exposed or hidden fasteners. In the top right photo, you can see that there are screw heads on all of those pieces of metal. So that does come with a little bit of long-term maintenance because rubber seals on those fasteners are eventually going to wear out and leak, but something to be considered. And then there's standing seam roofs, which is like that cabin photo in the middle there with the red walls. So standing seam panels are usually rolled out on site, cut on site, and formed on site to fit the roof as it's made, unless they're kind of prefab, which can be done. But that is what they look like. Frequently, the fasteners are hidden. When you install one panel, the fasteners go next to the panel, and then the next panel covers them up. So you end up not seeing any fasteners. It looks very sleek and modern, looks really nice. So that's another look, is the standing seam. And stone coated is effectively rarely done, but it's done in the case where you want your roof to look like it's not a metal roof. And they literally will coat it in asphalt and ceramic particles, or they'll coat it in stuff that makes it look like a clay tile and stuff like that. Not as common just because it's an extra thing for looks, but it is possible to do, and it's a category. And then when you're picking out a metal roof, you're also going to want to be concerned with the gauge of the metal. So they usually make them in gauges from 20 to 29. The lower the number, the thicker the metal. And most of the time, you're going to buy 24 or 26, sort of in the middle. If you're in an area where you may get a lot of hail, you might go up to a 22, maybe a 20 if you're crazy. But most of the time, not going to happen. It's going to get cost prohibitive to do that. But you don't want to buy like 29 gauge metal either, because you walk on it or something touches it and it's just going to put a ding in it, and that's the problem. So frequently, I heard a story from a builder where he strictly uses 22 gauge or something on the stronger side, and all the other guys in the neighborhood had done it with a cheaper gauge, and a big hailstorm came through, and everybody's roofs had a bunch of dings in them, except for this one guy that he built, which had the tougher gauge. So it can be worth it if you want to pay for the longevity and the toughness. So here's an example of the Tesla roof. This is what the panels look like. It's pretty much this. On the back side of each one of these panels is a bunch of wiring and a bunch of clips. There's a bunch of wood strips that are put down. There's a sort of a fancy way to connect all this stuff together, but this is what it looks like. And not all of these shingles are producing power for the house. It's usually selected shingles. So just that is there, but they all look the same. That's a Tesla roof. And this is what the example of that F-Wave synthetic. It's got a regular asphalt shingle on the left, and it's showing what the synthetic looks like next to it. It's designed to mimic it, but it basically says you don't have any granules that are going to fill up in your gutters, and you're not going to have granules that fall off and therefore reducing the resistance to UV damage. It's just going to last a lot longer. It's tougher. It's better. And this is all of the things they claim. So it is more expensive, but it's just one of those new products that's out there. These are cedar shake shingles. The one on the right looks somewhat nice, and the one on the left does not look as nice. Wood is an organic material, therefore water combined with wood, which is frequently what a roof will see as water, is not as easy to maintain. It has to be very, very carefully dried. If you're in a place with woods and a lot of shade, you're definitely going to get not mold, but moss and things growing on it. So it does look very nice though. So if you can afford it, it is also extremely expensive to install. You're going to pay a lot of money and pay a lot of money in maintenance. And it hopefully just looks nice enough to you to justify that. Tile roofs can be made out of different materials. There's concrete tile in the top photo there. There's clay tile, which is in the right photo. And there's slate tile, which is in the left photo. These are just three different products of tile. They serve different purposes, cost different amounts. The concrete tile is usually the cheapest one, but it comes with the lesser longevity. The UV damage is going to break down the concrete. It's not going to look the same. Clay is going to stand up a lot longer. It's usually going to be stronger, not as big of a deal. And then the slate tile is going to have a very special look. It's going to last a very, very long time. And usually slate tile develops a really cool coloring, depending on what climate you're in. The rock is going to patina in a special way that's going to make it look really cool. So these are very expensive roofs, but they do last a long time. They stand up very well to a lot of heat and just the abuse that comes with a roof. There's two styles of the clay and the concrete that you can get are barrel and flat. There's many shapes of barrels that people make. The concrete one looks kind of wavy. The one on the right is a flat tile, but you can just kind of get whatever suits you. Well, those are tile roofs. Here's an example of a rubber roof in the top right photo. What you're seeing is the recycled rubber shingles. That's what they look like. And the basic premise is they just take a bunch of rubbers that can't be recycled, like tires and things like that, and they manufacture them into new products. There's some super cool advantages to rubber. It doesn't tend to be, it's a little more expensive to get on here because it is less frequently used. Therefore, labor is going to be harder to find, and the materials themselves are going to be a little more expensive, but they are, you get to claim that you're recycling unrecyclable rubber, and they actually do stand up pretty well to abuse. The rubber material, just out of the fact that it's rubber, is going to have things bounce off a whole lot more than damage the rubber shingles themselves. So they're just very, very tough. And the one you see on the left is it's the single ply membrane roofing, where you apply sheets of it or you apply strips of it and you end up gluing them together. There's three types. ethylene, propylene, diene monomer, polyvinyl chloride, and thermoplastic polyolefin. Couldn't tell you about a ton about the differences between them, but this is generally what's going to be applied to low slope situations, which it can come up in residential cases when you have very fancy designs, but that's really what should be used in low slope. So underneath your roof or underneath those shingles and all those things, you're going to be worrying about your underlayment. So the underlayment's job is to waterproof the roof. The shingles job is to protect against UV, flying objects, falling objects, get most of the water off the roof. But ultimately, the true waterproof barrier is the underlayment. There are special products there's multiple kinds, but there's special products. In the top right photo, you're seeing Grace Ice and Water Shield. That is designed to be a very good barrier against ice and water. They're putting it on the eaves and they're putting it in the valleys because those are frequent leak areas, and they want to make sure there's not going to be any leaks. And it's a good idea to put it on your eaves because eaves is where ice damming happens. The valleys, it can happen as well. But effectively, if you got snow on your roof and sun comes out and starts to thaw everything, it's going to start melting all the ice or all melt all the snow on your roof, which is going to turn into water. The water is going to run down to your roof. It's going to run down the roof, and then it's going to try to go all the way to the eave, but the eave is overhanging the house. It's not part of the house, and if it's cold outside and snowing, your house is likely warm, so your attic is also warm. So you get this water running down your roof from the attic being warm, and it gets to the eave where the eave is cold because it's outside. Eve is the sheathing, the roof deck is cold. It's not part of the attic. So it freezes there because it comes back into contact with really cold air, freezes, turns into literally a dam of water, and then the water builds up on your roof and makes a pool. So if you don't have a really good substrate there, it's going to go right through any felt paper, any crappy underlayments. So you want really good stuff where ice damage is a thing. So yeah, the types of roofing underlayment generally are the felt, which is what you see in the bottom left. It's an older style. There's two types, 15 pound, 30 pound. It's just literally one's twice as tougher as the other. Twice as tough as the other. And it's just, it's the cheapest solution. It's the least lasting. You wouldn't want to take felt underlayment and put it underneath a tile roof, for example. That would be kind of dumb because the underlayment is going to fade out and not do its job way sooner than the tile is going to go bad. So you'd want to use good products underneath a longer lasting roof. But there's felt, there's self-adheres, and there's synthetic. So self-adhered is pretty self-explanatory. It's literally like a big sticker. You unroll it and stick it to your roof, and it's very good at being waterproof because there are no gaps for the water to get behind if you've shingled it properly. So what makes a roof assembly? Well, if you walk up to a house that's been decked, one of the first things you're going to do is you're going to start at the bottom always, and you're going to work your way up the roof because that's how you want everything to shingle so that water always falls down onto the next thing, onto the next thing, onto the next thing, off into the gutter or down to the ground. So the first thing you're going to run into is your metal drip edge / gutter system. In the top left photo, what you're looking at is a special edge that's been attached to the roof that's designed to catch any dripping water that comes off the shingles and kick it out farther away from the house, away from the fascia board, and ideally into a gutter for it to be collected and taken somewhere else instead of falling to the ground and splashing water and junk up on your house. So that's the first thing that's going to happen. And then you're going to put some kind of underlayment or ice and water shield, depending on if it's the same thing or if it's not. You're going to put that eave, that roof edge protection on top of that. And then you're going to go up the rest of the roof with all your underlayment, cover up the whole roof, make the whole roof waterproof. And then the flashings, depending on the situation, the flashing can happen as you're doing the shingles. Like in the bottom right photo, it's showing step flashing being installed up a chimney side or like a wall or something like that, where you got shingles going up. The wall flashing is installed so that if water runs down the wall, comes onto the flashing, it runs onto the next shingle instead of running down underneath the shingles. So that's how that's done. But that's an example of a flashing. Those can go on before, they can go on during shingles. It depends on what the situation is and where you're flashing. And then there's venting, like in the far right photo. That's a bathroom vent or an exhaust vent of some kind that's just inserted in there so that you got a pipe coming up through the roof deck, and you need to let it vent, but you don't want rain going down the pipe. So you're going to put this thing in here. So there's going to be penetrations in your roof, and they need to work their way in with your shingles and their waterproofing. And of course, the shingle, tile, metal layer, whatever is going on top, that's the actual roof structure, roof material is going to go on top of all that stuff. So an important thing to think about when you're considering roof pricing is that you should not just look at the cost per square foot, because there is more factors than that. If you buy a cheaper product that lasts shorter versus a more expensive product that lasts longer, in our example here, if you were to pay $2 a square foot for roof A that lasts 20 years and $4 a square foot for roof B that lasts 40 years, and they were, let's say, to actually last that amount of time, then the value of the roofing is the same. What you need to consider then is, what is the purpose of the thing you're building? How long do you care? If you're 90 years old and you're replacing your roof, you probably wouldn't pay for a 40-year roof, just saying. But, things to think about. And if you don't have enough money and you can't afford the longer one, just pay for the cheaper one. And you're not necessarily getting a bad deal. You just have to, again, you're going to end up replacing it sooner. But it's just, the same value over time. So you just want to make sure you take your price per square foot and divide that also by the amount of time to get price per square foot per time, so that you know that the roof is, a good value. Ventilation. So ventilation is extremely important, because if your roof gets too hot, well, it's important for a lot of reasons, but a very important reason is that if your roof gets too hot from the sun hitting it, it's going to break down all the shingles. It's going to kind of burn them up. They're going to get overheated and they're going to start to fail, and it's going to wear your roof out much faster. We don't want that. It also causes extremely hot attic would be a problem for the inside of the house too, because if you don't, you got some insulation in your ceiling and it's not very good, you're going to lose a lot of heat, and you're going to gain a lot of heat in your house. Either way, it's bad. So you want a well ventilated attic in most situations. If you don't have an attic, then there's other ways to deal with that, but we're not going to quite talk about that at this time. So if you have an attic, it's ventilated, you want to move air through the attic. Well, how do you do that? Well, back in the day when houses were super simple and they're just kind of like a big long house, they would take basically a big vent grate, and they'd put it on one end of the house, they'd put it on the other end of the house, and air would kind of like wind would push air through the house, sort of. It wouldn't vent very well, but it's just the way they did it. And then as they learned more about how to handle airflow, they figured out that, okay, when you put holes in your soffits that overhang the house, it's going to let air into your attic. And if you put holes near the top of your attic, it's going to let the air out of the attic, just because cold air is going to enter. It's going to heat up because the roof is being cooked up by the sun, and it's going to be blasting this heat. It's going to be radiating all this heat down in your attic. It's going to heat up all the air. That air is going to want to go outside because it's warmer than all the outside air. So it's going to go out those air vents. Now, so cold air flows in through your soffits. Hot air flows out through the ridge vent or turbine vents. The photo in the top right is a turbine vent. You can also install ridge vents that basically just kind of go up underneath that top ridge shingle. They're much less. They're much nicer to look at. You don't really see them usually. Better than a big turbine, and there's no maintenance required because the turbine's got to spin. But that is the basic premise. So the way we measure that and account for that is what is called net free area. And it's basically measuring how much total area do you have in your entry to your attic for air? How much total area do you have for your air to exit your attic? I said in here that you want to favor the supply air, and that you'd want more airflow to get in your attic than to leave your attic. The reason that is the case is if you have much more airflow leaving your attic than can get in your attic, then the air is going to flow. And that means it's going to suck the air out of your house instead of going up through the soffits. So that's bad, because you're trying to condition the air inside your house, or you're trying to heat the air inside your house. You want to keep the air inside your house. You don't want it going in your attic. So you want to favor the supply of air so that you don't get suction in your attic pulling air out of your house. So that's encouraged by the code, because the amount of net free air is kind of said by code, and they say, well, okay, if you have a roof area of 150 square feet, then you need 1 square foot of net free air that's venting. And you're, in a good situation, you would put half of that high and half of that low. In the old days, you would take half of that area, put on one end of the house, put half of that area on the other end of the house. So the net free area is described as effectively the soffit material you see on the bottom right photo is a bunch of little holes poked in the soffit, right? So Hardy, who manufacture, well, if that's Hardy and they manufacture that, they're going to have a table that says the sum total area of all those holes is this per linear foot of this soffit stuff being added onto the house. So it's all stuff that when you buy, if you buy that turbine, it's going to tell you how much net free area is there that air can escape this turbine vent. Ridge vents, it's going to say the same thing. You just got to look through the description, the specifications. It's going to get all these numbers. So that's where you get these things. That's where you know how much air is going to move through my material here or my item. So typical code is 1/150. Now that may require a large amount of venting area. So you'd want to ask, well, how can I reduce that amount of venting area? Well, that's the way you do that is you vent properly, you vent well. So you are allowed to do 1/300 of your roof area if you meet some certain exceptions. The first one is if you're in a cold climate, you need a vapor barrier on the warm side of your ceiling assembly. And what this is basically doing is it's saying if you, so what it's saying is if you have 1/150, you need to move a lot of air. That's what that's saying. You need a lot of venting area. If you want to ventilate less, aka risk leaving the air in your attic longer, then what's the problem with that? Well, if the air is in your attic longer, then it's going to heat up more or cool down more, and it potentially might have more vapor problems effectively. So by putting in a cold climate where it's a problem, by putting the vapor barrier in, you're basically negating any impact of lesser ventilation. So that's sort of a reason. That's not as quite the important one. The more important one is that you favor the low side of the ventilation. So the way they say that is 40% to 50% of the net free air is on the high side of the house. So if you do that, then you are allowed to only ventilate 1/300, and that's sufficient ventilation. So basically the reason there's a 40 to 50 is you wouldn't want to go like 30/70, because when you go too far, then you're not going to ventilate enough, and you're going to be effectively limiting the house. If you have this huge attic and you put a tiny hole in the top of the attic and you have tons of eave vents all the way around your house, your attic is not going to ventilate because the hot air can't get out. So you don't want to go too far, but you also don't want to go too much and suck air through your house. So that's why there's a 40 to 50% range is a happy one. So that's something that when you're designing the house, you kind of want to know. It's a good idea to have an idea of how balanced you're going to be. This is something that I always included in my architectural plans on a roof plan, is that, hey, when you're doing this house, make sure if you're doing hardy soffits, you got this many linear foot. I don't know what material they're going to use to do these things, so like I'm just guessing, but use this many linear feet of hardy soffit wherever, and then use this many linear feet of ridge vent or whatever it may be, or this much to the turbines in the ridge vent. So it just helps builders. So if that wasn't enough and you want to learn more, there's way more to learn. I would just summarize pretty much everything there, but you ought to watch a YouTube video, What to Expect When Changing Your Roof by Home Renovation DIY. He also has another video of that is called What Roof is Best for Your Home, Architectural Shingles versus Metal Roofing. And there's another one, 2023 Roofing Materials Guide, F-Wave, EuroShield, Asphalt Shingles, Metal, Cedar, and Tesla Roofs by Roofing Insights. These are just some examples. Like I said, there's tons of information. There's tons more detail I could go into. There's, of course, lots of information that should be learned on, okay, I've picked out the roof that I want. How the heck do I install it? Well, the first thing, go read your manufacturer specifications, and then maybe watch some YouTube videos and stuff like that. So that's pretty much it. So let me see if I can do this from here. I can't stop the recording. So thank you for watching Bungalows for Bachelors. We will see you next week.